This is Team CityScale. I'll turn it over to them.
Thank you so much. My name is Thomas Marconi.
Hi, my name is Schmidt Joseph.
Hi, my name is Andrew Mahorner.
First off, we just want to take the time to thank all the judges and the mentors, especially Mr. Dan, for his help and for your time today. So next slide. So what's the problem? We chose number 2. So really what we're seeing is we have data, we don't know what to do with it. These policymakers, they have spent a lot of money collecting data. Now, how do we get actionable insights from that? So our main problems are disparate and complex dashboarding tools that don't really drive insights. And we want to have an easy way to interact with the data, not just view it, but actually manipulate it and see how different factors are going to impact those affordability indexes. So why do we choose this? We believe democratization of data, and by increasing that, it's going to allow for a more available data set, or more available information so people can make data-driven decisions. So our solution, we generated a PCA-based housing affordability and risk index analysis across all 25 cities. So the main features of this, so we have a heat map dashboard, a set of filters that actually let you filter the different tracts by whatever you're looking at, whether you want to see which tracts have greater than 25% of SNAP housing usage. You can see that to really pinpoint what you're looking at. We also included a chatbot for natural language data analysis, similar to some of the other teams. And the impact mainly are for policymakers, real estate planners, and nonprofits. And we want to be able to use these data to drive actionable insights to really help the people. We don't just want this to be a project that we make over a weekend. We wanted to actually be able to change the cities that we live in. Next slide, please. This is a quick screenshot. We're going to get more into this towards the end, and we'll have a demo, but I just wanted to include this to have it there. So how did we clean the data? So over on the right, we just have a picture of our SQLite database. Mainly we got the data in a bunch of CSV files. There's never a way to programmatically interact with that. So I created a SQLite database and then a fast API to interact with that data. The main things I wanted were to retrieve all features for a tract, retrieve all features, retrieve a specific feature for a tract, and then retrieve all the tracts in a city with their features. So we also included, so the entire feature set is 178, and I'll get into our methodology, but we turned that down to around 40 for our PCA. So our method description, we used unsupervised PCA. And so why do we use this? We didn't have any label training data to correlate with until afterwards we found a data set of evictions for particular tracts, and we sort of correlated to see how accurate we were. So we tried to pull out from the data set which features were most correlated with each other to try and derive some insights. So our main 5 steps. So we created a PCA for the entire data set, so it's across all 25 cities. And then we apply that PCA. So first we label all of the PCs that are generated by that. We standardize them using a Z-score. And then we use that to then create a composite score for each city. And then we redistribute that on a 0 to 100 scale for the UI for better understandability. So these cities and the tracts are distributed across the entire data set. So you can see not just how it affects your city, but also compares to other cities. So pass this over to Andrew.
So here we're looking at our performance results, and in this we compared our tract level risk scores with Eviction Lab's eviction rates. So we classified it into low, moderate, and high risk buckets, and then analyzed via a confusion matrix. In our findings, as the real world risk in the rows increases, the predicted scores in the columns will trend higher, which shows a strong directional alignment. But do note that the model outputs are a bit more conservative because we incorporate much more broader socioeconomic factors beyond just eviction rates. And then some of the big challenges we faced were, for one, lack of domain knowledge. So pretty much none of us had any experience using unsupervised learning. So the mentors and SMEs definitely helped us out working on those and giving us some ideas. And then the feature set was definitely too complex to start. There was such a big list that it was really getting confused with what it was doing. So we definitely trimmed that down to what was relating best to the data. And then creating a model that accurately predicts the outcomes with that. And then we were missing the track coordinates and shapes. So that was a challenge to overcome to implement them on the map. And then our chatbot in the early stages was having quite a few problems, especially with the amount of data it was given to try to process it. So when we reduced the feature set, that definitely helped it out a lot. And then we'll move on to the demo. I'll pass it back to Thomas.
Yeah, thank you, Andrew. So we can go ahead. So we have it pulled up City Denver, so we'll actually go to Jacksonville. So you have an easy interface in the top left to select the cities. From here, what are we looking at? You have the entire city here split up. Higher numbers are bad, so red is like closer to 100. So I'll go ahead and click on a track. But before I talk about that, I want to talk about what's on the left. So let me zoom in a little bit. So a big thing about these dashboards is like you want to understand like where the data is coming from. You don't just want like a number. And so we talked about the global PCA model, the tracks that we trained it on. That's like the features times all the tracks. All the PCs, we came up with 6 of them, and they explain about 66% of the variance within the data set. And what's really important too, so we have the global score range of all cities, so you can see the mean level is 50, because we standardized it like that. We have the min is 0, max is 100, just to explain that to users. But then we have the mean and the median for Jacksonville itself. So the min is 1.1 and max 97.8. And so as we go down, really focusing on that interactability, we have each of these PCs labeled, and you can independently weight ones more or less. So for example, I rated this one as a 2 for economic hardship. So it explains it right there. Higher weight equals more importance to tracks with economic hardship, higher scores for low income areas. So if I click on this now, it's going to be 86.6, but if I move it back down, it's going to be 87.4. And so another aspect of the interactability that I mentioned was the filters. Say we want to filter for households receiving SNAP, like I mentioned, percent greater than or equal to 10%. I was actually going to filter out a decent amount of these, so that you can really understand like what your data is doing and where does it apply. On the right side, we have that housing risk index score at the top, and then broken down, we have a specific score for each PC, and then those are sort of like, those are then massaged into the overall score. And then just here, we also included all of the factors that that are part of the data set, just again for visibility, so that you're not just looking at one random score, you can actually see what is affecting each of these tracts. Anything else, guys, for the demo?
The chatbot.
Oh yes, and then the chatbot. So, like I mentioned, natural language analysis, so if you could hold the mic for a sec. So I'm asking it, what factors are influencing the housing risk score? So we're actually just passing it, it's very naive, but we're passing in essentially what's in the right side of the app, and then it's generating something. But we want to go back to, and so it gives you the ability to see policy decisions and stuff. So we're going to go back to this for our last slide. Okay.
Yeah, so when it comes to our applications, if we just had more time, we could pretty much build a new team to get new data. So pretty much we don't know what exactly our data is coming from. So we wanted to, if we have more time, build a new team with the city to survey around the city to understand, to get more data for that. And then also our other applications that we wanted our next step to be is to fine-tune our model. Pretty much it kept on hallucinating. As you can see, it's more naive. We just had more time just to train our model for it to understand the policy levels, to give pretty much to give the policymakers better understanding. Sorry.
Thank you.
I know you mentioned that you got some help from the mentor for PCA. The only reason I'm asking this question because it seems to me you have mapped the PCA space with the input variable almost one-to-one. I'm just wondering how was it possible? Like I saw 6 components and you mapped those 6 components with one input variables.
Yes.
Yeah, so how did you map one-to-one?
I think so. The PC1 describes a greater amount of the variance in the data. So to our understanding, that was able to.
But that does not say only one importance of the input variables. Normally it is a sum, like a linear sum of many variables. So how did you choose one variable? Did you cut off everything else? I'm just wondering.
That's a good question. Basically, it was like an averaging of the different scores for the different weights that the people are associating with them based on the variance.
But then why I will use PC? I will just take that input and then I will just one regression and I will take overall economic health. Sorry. And what I'm saying then, like if you can map one PCA with one input variables, I can just use my model without the PCA.
You could do that. Sure.
Okay.
Yeah. What we did was we tried to aggregate all of those, in some way.
Your input allows for adjustment of the weights.
Yes.
Why would you allow an end user or someone else to adjust the weighting and shift the results? And shouldn't the weighting be determined by your SMEs in that area, and then really not allow someone to manipulate results?
Yeah, that's a good question. Our thoughts were, if you're actually wanting to look at the data and interact with it, okay, so what if we made the urban density weight a lot less? How would that actually influence things? Okay, so we've implemented this policy. Now we have new scores for the different areas. So it was kind of the idea of like what would be the impacts of the policies that we would implement in these various areas.